Okay. In this tutorial we're looking at section 5.4 on applications of exponential functions. So our general exponential equation is, as you can see there, it's a equals a naught e to the kt. A naught is our initial amount, okay, k is just some constant and t is time. Okay, so it's just application type questions for this. So there's one worked example that we can have a look at. Okay, so we have the number of bacteria on a culture plate N can be defined by the rule NT equals 2000 e to the 0.3 t, okay, where t is greater than or equal to 0. So t is our time, so time has to be greater than or equal to 0. Okay, and we know t is in seconds. Okay, so part A, okay, is how many bacteria are initially present. So we can do this a long way. So basically we're saying what is, for A, what is n of 0, so when t equals 0, so we can say, well, we've got 2000 e to the 0.3 times 0, well that equals 2000 e to the 0, anything to the power of 0 is 1, so our answer is 2000 bacteria. Okay. Of course, we could have just looked at our rule and known that our A naught value is our constant out the front, and that's our initial amount, so we could have just said straight away that we were 2000. Right, part B is how many bacteria to the nearest whole number are present after 10 seconds. So for B, we're looking at n of 10. So we're saying we have 2000 e to the 0.3 times t. And our t, we know that is times 10. So that's 2000 e to the 3. Okay, which gives us, when you do e cubed and times it by 2000, it gives us 40,171 bacteria present. Okay, and then part C, okay, is at what rate is the bacteria population multiplying after 10 seconds? Give your answer correct to the nearest whole number. Okay, so we want the rate of change. Because we want the rate of change, it means that we're going to be differentiating our function. So we've got our function, n of t, equals our 2000 e to the 0.3 t. Okay, so n dash of t, well, it's our 2000 times our constant out the front, 0.3, times our e to the 0.3 t. Okay, if you have a look back at section 5.3, you'll see our tutorial on how to differentiate exponential functions, if you're having a little bit of trouble with that. Okay, so we can simplify that. Our 2000 times 0.03 is going to be 600 e to the 0.3 t. Okay, and we want to know how many there are, what our rate of change is at t equals 10. So we want n dash of 10. So that's 600 e to the 0.3 times 10, which is 600 e to the 3. Okay, and when we work that out, it's 12,051. Okay, so after 10 seconds, the bacteria are growing at a rate of 12,051 per second. So bacteria per second. Okay, so as per usual, application questions, really fundamental, really important. These are the type of questions that you're going to get on exams and SACs. So make sure that you really got a good understanding of how to do these type of questions.